Hello Jerry, thank you for joining me today. How are you?
Hello Joanna, great. What about you?
I am doing well, thank you. Today, we'll be discussing some key features of Python and answering any questions or doubts you may have. Are you ready to get started?
Absolutely, let's dive in.
Great. To start, one of the main reasons Python is so popular is because of its simple and easy to learn syntax. Python's syntax is designed to be easy to read, making it an ideal language for beginners. Its concise nature makes it easy to write code, reducing the time and effort required to develop applications. Do you have any questions about Python's syntax so far?
No, I'm familiar with the syntax. It's one of the reasons I enjoy using Python. What else can you tell me about Python?
Python is a high-level language, which means it abstracts away the low-level details of the computer, allowing developers to focus on the logic of their application. This makes Python code more readable, maintainable, and faster to write than low-level languages like C or assembly. Have you worked with any low-level languages before, and if so, how would you compare your experience with Python?
I have some experience with C, and I find Python much easier to work with. The readability and maintainability of Python code are definitely big advantages.
That's a common sentiment among developers. Another important aspect of Python is that it has an interpreted language. This means that code can be executed line by line without the need for compilation, making it ideal for rapid development and prototyping. Have you ever encountered any issues or benefits with Python being an interpreted language?
I've found that it's really helpful for quickly testing out ideas and making changes on the fly. The only downside I've experienced is that Python programs can sometimes be slower than compiled languages like C or Java.
That's true. The trade-off for rapid development can sometimes be a decrease in performance. Another key feature of Python is that it has a dynamically typed language. This means the data type of a variable is determined at runtime, which makes it easier to write code since developers don't need to worry about declaring data types. However, it can also lead to some runtime errors if the wrong data type is used. Have you ever encountered issues with Python's dynamic typing?
Yes, I've run into a few issues where I've accidentally used the wrong data type. Thankfully, Python has good error messages that help me quickly identify the problem.
That's good to hear. Python's large standard library is another reason it is so popular. The standard library includes modules for many common tasks like file I/O, networking, regular expressions, and more. This makes it easier to build complex applications without needing to write custom code for every task. Have you used any modules from the standard library that you find particularly useful?
Yes, I've used the OS module for file system operations and the RE module for regular expressions. They've saved me a lot of time when working on various projects.
Indeed, Python's standard library is a great resource. In addition to the standard library, Python has a vast ecosystem of third-party libraries and frameworks that extend its capabilities even further. Some popular libraries include NumPy and Pandas for data analysis, Matplotlib for data visualization, scikit-learn and TensorFlow for machine learning, and Django and Flask for web development. Have you used any of these libraries or frameworks in your projects?
I've used NumPy, Pandas, and Matplotlib for some data analysis projects. They've been incredibly helpful and easy to work with. I've also heard a lot about Django and Flask, but I haven't had a chance to use them yet.
It is great to hear that you've had positive experiences with those libraries. Python's cross-platform support is another important feature. Python code can run on many different platforms, including Windows, Mac, and Linux. This makes it a popular choice for developing cross-platform applications. Have you had any experiences developing cross-platform applications with Python?
Yes, I've developed a few applications that needed to run on both Windows and Linux, and Python made it really simple to ensure compatibility across both platforms.
That is excellent. Python also supports object-oriented programming, OOP, allowing developers to organize their code into reusable classes and objects. This makes code more modular and easier to maintain over time. How has your experience been with using OOP in Python?
I've found OOP in Python to be quite intuitive. The ability to create reusable classes and objects has made my code more organized and easier to maintain. I also appreciate Python's support for multiple inheritance and how it simplifies the use of mixins.
That's great to hear. In addition to OOP, Python also supports functional programming, allowing developers to write code using functional constructs like lambda functions and higher-order functions. This can lead to code that is more concise and easier to reason about. Have you had any experience with functional programming in Python?
I've used lambda functions and the built-in map, filter, and reduce functions in some of my projects. While I don't use functional programming exclusively, I find it helpful to mix functional and object-oriented approaches when it makes sense.
That's a good approach, as Python's flexibility allows for a combination of programming paradigms. I hope this discussion has been helpful for you, Jerry. If you have any more questions or doubts about Python, feel free to ask.
Thank you, Joanna. I do have one question. With Python being an interpreted language, I've noticed that sometimes the performance can be slower compared to compiled languages. Are there any ways to optimize Python code for better performance?
That's a great question, Jerry. There are several ways to optimize Python code for better performance. Here are some suggestions. Use built-in functions and libraries. Python's built-in functions and libraries are often optimized for performance, so using them can lead to faster code execution. Use list comprehensions and generator expressions. These constructs can lead to more efficient and faster code as they are optimized for their specific use cases. Profile your code. Use profiling tools like cprofile to identify performance bottlenecks in your code and then optimize those parts. Use the right data structures. Choosing the right data structure for your problem can have a significant impact on performance. For example, using sets for membership testing is faster than using lists. Use a just-in-time (JIT) compiler. Compilers like PyPy can improve the performance of your Python code by compiling it to machine code at runtime. Use Cython. Cython is a superset of Python that allows you to write C extensions for Python. By converting performance-critical parts of your code to Cython, you can speed up execution times. Remember, though, that optimization should be done carefully and only when necessary, as it can sometimes make code less readable or maintainable. Always profile your code first to identify the areas where optimization will have the most significant impact. Do you have any other concerns or questions about Python's performance?
No, that's very helpful. Thank you for the suggestions. I'll definitely keep them in mind when working on performance-critical projects.
You're welcome, Jerry. I am glad I could help. If you have any more questions or need further clarification on any Python-related topics, please don't hesitate to ask. I am always here to help.
Thank you, Joanna. I really appreciate your help and expertise. I'm sure I'll have more questions in the future, and it's great to know you're here to assist.
You're very welcome, Jerry. I look forward to our future discussions and helping you with any Python-related questions or concerns you may have. Have a great day.
You too, Joanna. Take care.